It's time for us to take all the different things we've been learning this semester and apply them to the geology of California. We're going to do this by looking at a geologic map of California and trying to understand all the different parts of it. This video will introduce you to the map and get you to put the igneous rock units onto the map. Actually, you don't have to make the map, you just have to color it, which is more fun. Here's the map that I want you to print and color. And I know it looks kind of busy, but as I said, I'm going to walk you through this in several different videos. Notice that in the bottom left corner there's a major geologic unit section, and these are the rock units that are presented in here with the different patterns. Whenever we have a geologic map, we always put the rock units on from youngest at the top to oldest at the bottom. And so we have 7 different units that we're looking at in this map. In reality, California has many more units than that, but this is a simplified version. Eventually, our map's going to look something like this. This is not exactly the same map. It has a few more divisions in it. But what you can see, I think, is that when you have color on the map, you can see rock units much more quickly and they can make more sense than when you just see everything in black and white. Here's the legend blown up. Notice that below these rock units, we also have some symbols for geomorphic province boundaries, which we're not going to really worry about, geologic unit boundaries, which simply divide the different patterns, and faults, which are slightly darker lines, and you can see quite a few in here. Some of them are even labeled: San Gabriel Fault, Santa Ynez Fault, Big Pine Fault, of course the San Andreas Fault. And then we have this scale bar down here. In this video, we're going to talk about the 2 major igneous rock units that are on this map: the Quaternary and Tertiary volcanic rocks of the Cascade Ranges and the Modoc Plateau, and you're going to be coloring these pink, and the Mesozoic, Paleozoic, Metamorphic, and Granitic rocks of the Sierra Nevadas and some other regions, which you're going to color red. Now you see it says metamorphic, so we have actually combined quite a few things on this map to simplify it. It's just the way we've got to do it. We can't make it as complicated as reality is. This is what your map should look like after you've colored those 2 rock units. The Modoc Plateau is in the northeast part of the state, and then the red granitic rocks are in the Sierra Nevada mountain belt, the Klamath Mountains, and the Peninsula Ranges down here in the south. And then they're also kind of sliced and diced by the San Andreas Fault system in regions here. So let's take a look at how these rock units formed. We're going to draw some pictures, so make sure you have your colored pencils out and some paper. We're going to do a Mesozoic subduction cross-section here, and we're going to have west on the left and east on the right. First, I want you to draw 2 plates that are heading towards each other in a subduction zone. The one on the left will be the Farallon plate. The one on the right will be the North American plate. Let's throw in the Pacific Ocean, just so you're clear where sea level is. These plates, again, are moving towards each other. And this is what was happening for 100 million years in the Mesozoic. Remember that when we have subduction, volatiles from the downgoing plate can lower the melting temperature in the asthenosphere and create flux melting, which causes melting of the asthenosphere. That melting will produce magma that might pond at the base of the North American plate, and then it might continue to heat up and melt the interior of the plate. These arrows are showing magma that's migrating through the plate to the surface, and if it makes it all the way to the surface, we get volcanoes. This is the subducting volcanic arc that we've talked about for subduction zones. But remember, sometimes the magma doesn't make it all the way up, and it stalls, and it makes these magma plutons. So here we have a scenario where we have extrusive igneous and intrusive igneous rocks forming above a subduction zone. No surprises here. We've learned about this before. Because subduction lasted for such a long period of time, there was a huge amount of magmatism occurring, and this region of plutons became very large. In fact, we had plutons intruding more plutons, and I've shown them in different colors to represent different ages. And so we had this huge region of intrusive igneous rocks. So what happened next? Well, in the Cenozoic, eventually, at 30 million years ago, subduction stopped. At the same time, basin and range extension began about 20 to 30 million years ago. If you remember from the Yosemite field trip, I talked about this basin and range extension. Because the crust extended, we had a series of normal faults that helped the crust stretch in an east-west direction. And a major normal fault occurred at the eastern side of this region, which had most of these plutons, also known as batholiths, moved up relative to this side. And the volcanoes that were on top were eroded away. So here's a new picture for the present day. We have this big normal fault that's actually still active, and we have Owens Valley going down and the Sierra Nevada mountains going up. I've put these same colors in here to indicate that that's the rock type that was there. And again, the volcanoes that are up here are long since gone, although there are one or two that are left. You'll notice I also have labeled the Coast Ranges and the Great Valley, and we'll talk about these in future videos. So that's the story of the red rocks. Again, they've been uplifted. Basically, you can think about them as the roots of an ancient volcanic arc over a subduction zone. And a lot of them, like I said, have been sliced and diced in more modern times. The pink rocks are also related to subduction, but they're related to current subduction. And here we have a scenario very similar to what I drew earlier, but now this is where the Juan de Fuca plate is going under North America, and these volcanoes are actively forming. This is part of the Cascade Volcanic Range that includes Mount St. Helens and Mount Rainier and all those others up in Oregon and Washington. So that's it for now. Make sure you get those colored, and next time we'll add in the sedimentary rock units.